Alright, friends and neighbors, welcome back to the channel. Time now for another networking video, or is it? This time we're going to start our voice over IP journey. Now, I've talked about voice over IP before. We've talked about the components and things like that, but I thought we'd take a little bit slower look at some of the things and then maybe add some traditional telephony. In fact, that's where we're going to start. So our journey begins with a little traditional telecom. Now, what's kind of fun to remember is that there was a time when companies had much more than just one network. I mean, today, everything's on your one data network, your infrastructure. But historically, you had a network that ran all of your computers and printers and things like that. But there was this completely separate network for telephones. They had nothing to do with each other. In fact, today, we integrate the two sets of wiring maybe for telephones and data. Historically, we didn't even do that. So you had a completely set of different jacks and wires for telephones, completely set of different jacks and wires for computers. In addition, maybe you had another network for video conferencing, maybe one for security, and maybe even another one for your fire alarms and any other alarms, things with the elevators, all kinds of stuff. Today, almost everything runs on the IP-based network. Now, the other thing to remember is that we talk a lot about telephones today, but really when we're talking about telephones today, we're talking about cell phones or voice over IP phones. Historically, right, we had one set of very traditional phones. Those phones ran over what we call the public switched telephone network, or the PSTN. In fact, they still do today, although we use what we might call the traditional PSTN a lot less than we used to. Now, the PSTN is governed by a completely different set of rules. Although we'll see there are some similarities, it's a completely different set of rules. Didn't have IP addresses or anything, and it was called Signaling System 7. Now, that would sort of indicate that it came from someplace else, and there was, in fact, a Signaling System 6. And this all comes from what we call the Integrated Digital Network, or at least it has its roots back then. So it is this completely different set of rules, completely different architecture than we're used to thinking about when we talk about the internet. And of course, all of this is way before the internet as we know it today. In fact, it was way before the internet as we knew it back in the 1980s when some of the original RFCs were being developed. Now, what do I mean by traditional telecom? Well, as I said, it's a completely different architecture, completely different set of rules, so there are all these terms that we use when we start talking about traditional telephones. We start talking about the Bell system, or Ma Bell. The type of connections that we established were circuit switch connections. We time division multiplex everything together. On the local loop, we had something called the plain old telephone system, or POTS. And of course, we said things like PSTN and local loops. The wires that we were always worried about, the red and green pair, that was tip and ring. We talked about T carriers, or if you were across the pond, we talked about E carriers. We divided up our telephone connections or conversations into those covered by, or at least carried by, local exchange carriers, long distance service, inter-exchange carriers, and then we had this mystical, magical thing called dial-up networking that also had to use the traditional telecom system to send data from one place to another. So the original goal for the PSTN was one worldwide standard, and there are still lots and lots of efforts like this. But even today, when we talk about the similarities of cellular telephony or even how the internet works, there are differences between different geographic areas in the world today. But that was sort of the original goals. Now, one other thing that comes about from all of this is something called common channel signaling, where all of your management traffic travels over one channel. Well, what's a channel mean? Well, it could be wiring, or it could be bits stolen from individual channels. So, for example, in the middle of our data connections, there might be HTTPS or SSH traffic flowing in there too. And so that's an example of management traffic that might be flowing over the same channel or in-band communication. But common channel signaling was a mechanism used so that all of the management or data about the connection or data used to set up connection followed one particular channel. So Signaling System 7 is the system that coordinates the setup and teardown, billing, and all of that stuff for our connections. And there are some really interesting details about how it works. It's a little bit more than we want to do today because, after all, this is a networking channel and not a Signaling System 7 channel. But when you think about it, at the time you picked up the phone and you wanted to make a phone call. When you do it with your cell phone, you are establishing a connection initially with the telephone system. And you're telling the telephone system what number you'd like to dial, when you picked up the phone, and the telephone system in exchange is giving you signals like busy, off hook, dial tone, fast dial tone. All of these signals are coming to you from the public switch telephone network. When offices have to communicate with each other because you're making a call that travels across the state or across the country or across the globe, offices have to communicate to figure out how in the world they're going to forward your call but also terminate the call, and then, of course, how to recover resources when you're all done. So it's actually kind of amazing how the system was set up. Now today, of course, we use the internet, we use voice over IP, we use a lot of cell phones and the mobile telephone system, but there's still a lot of traditional telephony still out there. And so even though we have lots of migration away from the traditional telephone system and the way that we did things traditionally, there's still a lot of traditional use out there. And so these things still exist in tandem with each other. So this is just a quick look at Signaling System 7's model. And the only reason I really include it here is because a lot of the ideas that we have for networking models today, the OSI model and the TCP/IP model, come from the model that was used from Signaling System 7. I mean, take a look at MTP Layer 1. The message transfer part Layer 1 is for physical and electrical characteristics. Amazing. That's what we do with our TCP and OSI models too. MTP Layer 2, point-to-point between endpoints. That's what we do with Layer 2 here, except we talk about things like MAC addresses and building frames from one place to another. Layer 3 is for routing. How about that? Go figure. And then layers above that are for services and database access and things like that. So looks a lot like the models that we have today. So we have to remember that, you know, every idea that went on before sort of informs the ideas that go or that come after that. And it would actually be silly to try and reinvent things from scratch. Now, as a part of our journey, there are lots and lots of folks that really think Signaling System 7 is the bee's knees. And in fact it is. It works really well. But we have to acknowledge that there are an awful lot of trends when we look at how people use systems and data and things like that. So at the very top of this particular graph here, we can see this line here, this light blue line. This is growth in mobile cellular telecommunications subscriptions. So this would certainly tell us that what folks want to use are their cell phones. We've got another very high trend here for mobile broadband. Makes sense, right? Mobile subscriptions, mobile broadband. The number of individuals using the internet, right? So that's the service that everybody wants to use. So the internet, whatever that means to us right now, we haven't quite figured that out yet, but we'll get there. So these are our top trends. Let's take a look at the two bottom ones down here. Fixed broadband. That is folks that are using broadband in connection with a single location. Not as much growth, still a little bit of growth, not as much. And this poor sad line right here, fixed telephone subscriptions. Well, this has been sort of on the wane since 2004, 2005. So what this means is that folks are just simply not buying as many fixed telephone subscriptions. Folks don't want fixed telephone lines. That is a line that is a single circuit to a particular destination. Now on the graph on the right here, I've included this one because it's for one country, the the United States, and what this shows is the number of subscriptions over the last 20 years, obviously going down. If we bounce this against the population growth, it's actually worse than this. It's not just a numbers game, it's the numbers per the number of people in a particular geographic area. So that would actually make this a little steeper. So let's talk a little bit about some of the wiring that we've come to know and love. So cabling is a really, really important part of any infrastructure, and that's also one of the things that's, right in front of our faces. Now, when we talk about traditional telephony as far as a connection to your house, it's usually analog. Now, what we're forgetting here, I'm not paying attention to voice over IP, so this is not Skype, it's not Vonage, it's not Time Warner All-in-One, it's not none of those things. It's usually an analog pair or two pair of lines that come to your house, right? And that's why you see somebody out on the telephone poles messing around with connections. Now, this also means that all the homes in the neighborhood that still have a traditional telecom connection, this tip and ring pair, this local loop connection, in your neighborhood also have these wires coming out from their houses. And they have to all connect somewhere. So this somewhere in a neighborhood, there's oftentimes something above ground that you can see in somebody's front yard that is a junction box where all of these wires come together. So that means at that point there's a bundle of wires that goes off from your neighborhood or your street. Now, as we move towards the central portion of the network, as we get closer and closer to the central office, we get larger and larger bundles, and then we also start running into powered frames where we can do things like multiplexing into T carriers or things like that. And of course, the data running over all this, when I say data, it's not the same thing as internet data. It is the data necessary to establish phone calls, like the numbers that you're dialing, and then how long you're on the phone for, and when you hang up. All of that is handled by Signaling System 7. Now, there are limits to what we can do with that little pair of wires there, and the services that are available were offered by something called POTS, or plain old telephone systems. So these are the things where you would go *66 or *69 as a code that would send frequencies down to the central office saying that this is the function that you wanted to activate. Now, POTS and the local loop, very reliable, and it turns out that one of the reasons it's reliable is because we're not sending a tremendous amount of data. We don't have a lot of bandwidth that we need, and so, as long as the signal gets through, usually the service was just fine. Now, a lot of times what we would say is the connection to your house was a line, and when you had a bunch of connections, we would call that a trunk. And trunks were also the connections that we sort of referred to when we were talking about central office to central office sort of connections. And this is just a graphic that sort of shows how these things go together, right? We have our phones in our houses, and this connection right here is the local loop to the house, and it's got a punch down somewhere, an actual physical punch down where you connect the wires, and then that goes out to some neighborhood feeder or distribution frame. Now, I keep using the phrase tip and ring, and that is a reference all the way back to switchboards like this, where the actual physical connector that you stuck in the hole had two different connections to it. One was wired to the tip of the plug, and one was wired to a band that went around it called a ring. So that's why we call them tip and ring. And this is typically the red and green pair that we see in our houses. The other pair would be black and yellow. So when we start to put all of this together, we have to recognize that the Publishers Telephone Network is not a United States thing by any stretch of the imagination. It is a global thing. So even though we have United States organizations, everybody's country has their own organizations for managing all of this. Internationally, we have the International Telecommunications Union Telecom sector that governs a lot of how the Publishers Telephone Network operates worldwide. In the United States here, we had something called the Bell system or AT&T system, and that's because a lot of the equipment manufactured was manufactured or built by and managed by these companies. Now, there are a lot of other terms that go along with this. CLECs and ILECs and IXCs and LECs and LADAs. These are competitive local exchange carriers, incumbent local exchange carriers, inter-exchange carriers, and then just the generic local exchange carrier, local access and transport area, and then of course our area codes. So generally speaking, we have this image here, and it just shows us that on one side we've got, me or you trying to make a phone call to somebody else, in this case grandma. Well, that phone call goes out over our local loop, tip and ring, and gets to a local exchange carrier central office. And we'll see here there were some significant events that sort of shook up the telephone industry. But in this case, I'm going to show you that it goes to an inter-exchange carrier because grandma lives some distance away, some geographic distance away. And then eventually the inter-exchange carrier, like AT&T, would drop this down to another local exchange carrier, and then that would be dropped onto the circuit, the tip and ring pair, for grandma. And we would send signals down to that phone, including telling the phone to ring. Grandma would pick it up, and then we'd have our voice data traveling back and forth. And actually what's happening with our voice is that our voice frequencies, those frequencies from 300 to 3600 hertz, those are going down the channel, and then the subscriber line card is using a codec to encode that data. Now if we look on the right here, we can see that we've got that diagram that we just put up there. But today, of course, we have a very similar architecture where we have, a computer connection going to an ISP that goes up to a larger internet service provider in some cases, and then maybe down to a smaller internet service provider to get it to finally to the destination. And then the transmission comes back in the reverse. But there's this point at which the internet and the public switch telephone network have to sort of interoperate. And maybe the best way to sort of illustrate that is to talk about how dial-up networking worked. If you remember, or if you have one laying around, you can take a look at a traditional dial-up modem. And it has ports for a PC and ports for a telephone. So the idea is that you could pick up a telephone or use the computer over the same connection, but not at the same time if we're talking about dial-up networking. Well, a telephone uses a particular set of frequencies to communicate. And your voice uses a particular set of frequencies to communicate. When your computer wanted to communicate, it talks a completely different language. So, what would happen is your computer would send ones and zeros. Your modem would provide something called a carrier wave, and we would modulate the carrier wave with amplitude shift keying, frequency shift keying, phase shift keying, quadrature amplitude modulation. In that way, we would change the characteristics of the carrier wave to indicate ones and zeros. But before we could do that, your modem would actually do those funny beep, boop, boop, boop sounds. Why? Because it was dialing a phone number to another modem run by an ISP. And then we would modulate the carrier wave and then send that to another modem, which would then demodulate the carrier wave, pull the ones and zeros, and then we're back on the internet. If I wanted to use the telephone, then I would simply make my phone call as normal. It would go out to the local exchange carrier. The local exchange carrier would forward it on to the publisher's telephone network because it was just a voice phone call now. Now, the funny thing is that at that time, if you tried to use either one of them while the other one was in use, it would disrupt the other connection because, of course, you're using the same frequencies, the same part of the circuit. Well, I just realized we're starting to get a little long here, so I'm going to call this the end of part 1, and we will come back for part 2 in the next video. But in the meantime, while you're waiting, like and subscribe if you're enjoying the content, and may all your voice transmissions get to their destinations.